In this video, we will start a new series. We will be starting the beginner's guide to SDL2 in the Odin language. So this is Ginger Bill's language. It's low level. It's meant to be a replacement for C. It's called Odin. So if you want to follow along with this project, you'll need to go to github.com, Programming Rainbow, and this one will be called Beginner's Guide to SDL2 in Odin. Okay, and I just kind of want to show, if you're using YouTube, real quick, I don't want to mispronounce his name. I think it's Carl Zelinsky or something like that. He has a game he made in Odin, and he also has some tutorial videos that are pretty good, and I would recommend checking that out. And there is also some other people that do general tutorials. So those are on YouTube if you want to check them out. Then there's also the actual Odin website, which is really good to use. Sorry, this one. We're going to be looking at the package too for SDL2 as well, which is this, but they're the same website. This is odinlang.org, and this is docs and overview. And this one is the same website, but this is the package.odinlang.org, and this is vendor SDL2, and this one, you can look at all the kind of SDL2 stuff, but I also have the SDL2 website open that we'll be looking at as well. So to get started, the first thing we need is actually to get Odin onto our system. I have a little bit, this is for Arch Linux people, but there is no Odin package in the repo, but there is in the AUR. And so I didn't have any issues with it whatsoever. So you just kind of want to make sure you're in the top level directory. Then you want to clone the AUR. You want to go inside of the folder that is cloned, and then you want to do a make package -i. And there is no, you don't need super user privilege for this. You run it as a normal user. You do need to have super user privilege because it's going to install a package. You don't run it with sudo is what I mean. Okay, so I've already compiled it, but I'll just kind of show you what it would look like. So I would make sure I was in the top level directory, and do I have the website? Here's the AUR right here for it. This is the package that I used. And so it's just aur.archlinux.org, packages in Odin. Let me make it a little bigger. This git clone URL, I'm just going to copy this. And that would be git clone and there. And I've already got it, so it's probably going to tell me I've already got it. Yeah, I do. And then we'll cd inside of Odin. And then we would do a make package -i. And again, I've already installed it, so it's probably not going to do anything. It's just asking me, do I want to reinstall it? I'm going to say no, because it's already built. But it did take maybe 5 minutes to build this package or so, or maybe even longer. It was a little bit of time, but it wasn't a huge amount of time. I'm going to close this window. That was for how you install Arch Linux. So again, you do have to compile that package. And let's see. I do want to show real quick, if you're using my configuration for NeoVim for NVChad, I'm going to go into there and show you real quick. I'm only doing two minor things. I got an LSP running and I got syntax highlighting. So I'm going to go into there real quick. So this is my ~.config/nvim folder where your NeoVim or your NVChad setup is. And all I've done here is and you can do this directly as well, but in Tree Sitter, I've added Odin. I actually didn't add it here. I just went ts install Odin is what I did. And it's already installed. So, but you can add it here as well so it'll be there. If you ever delete your folder, it'll automatically reinstall. So I didn't actually add it here, but I did install it manually. I'm going to put it alphabetically here. So it would just be Odin. And that would be all you would need. Or you can install it manually with colon, capital T, capital S, capital I, the rest of it installed, and then space Odin. And that will get you the syntax highlighting for files. It automatically already understands what Odin files are, so there's nothing really to be done there. The other thing I did was in LSP config, I added OLS, which is the Odin language server. And all I did was stick it in here for the default. So I didn't do anything amazing. I just added it. This is going to automatically download it through Mason when I start up, but it's already installed for me. And this is just going to automatically configure it with the default configuration right here. And I'm doing nothing else. So that's going to get me the Odin language server up and running and syntax highlighting for Odin languages. Okay, so if you were using my configuration, those should be pretty simple. So let's check out a project real quick. And I do know that the way you're supposed to name the folder that you're working in, and I didn't do that, so I'm just using it as a single file. You'll see it here in a second, but I have the OLS running right here, and I have syntax highlighting for this. So I'm just going to show you what this looks like. If you've seen any of my beginner guides, it's going to be the same thing. We're going to have a window that opens. We're going to have music playing. We're going to have sounds. We're going to be able to control the sprite, and the text is going to bounce around the screen. So we could say Odin. Now again, let me explain this. The packages in Odin are very simple. Any module is just the name of the folder that it's in. And so if I were to name the folder, so I named this package up here main. If it was inside of a folder called main, I could just say Odin build main, and that would be it. That's all I would need for the whole thing. But I didn't do that because I have this, I'm trying to run multiple, I have code in different folders, and the name of this folder is Beginner Guide to SDL2 in Odin. So instead of that, you can just do the file itself like this. So the main.odin is the actual file I'm targeting. And I could just put -file, and that will work too. And this project's only going to be a single file, so this is going to work for us. But you don't actually have to run build. You could run build, then run. Well, I'll show you. I can run build like this, and this builds it. Now we have a new file here called main, which is what it just built, and I could just do /main and run it just like this. Now I'll show it. Okay, so we have Odin
obviously.
Bouncing around, and some random person with a red beard saying Odin. And whenever I press space bar, it says SDL, and I can move the SDL logo around manually. And we can change to a random color of the background, and that is about it. I can turn the music off, or pause the music rather, and I can close it. So that's basically building the file and running it, but I don't actually need to type that. I could also, instead of saying build, I could just say run, and it would just build it and run it. So that works too. Okay, so this is what the file looks like. We're going to break it all down and start building it from scratch now. So this again is on the repo right here in the programming rainbow, and there is a brief description of how to get it up and running. And what's happening here is the code for each one of these videos. This is video number 1. So the end product code will be in this folder. The code that's in the very top level, that is the final code. That's the video 8 code. So that's the finished project is what it is. So this code that we're looking at right here is the exact same as what would be in here. So whatever project you want to look at, or however you want to do it, you could just copy the code from any of these video files into the top level directory and use that one. And that's how I kind of set it up. So I'm going to delete this file, and we're going to start building it up. So this one is just the binary. I'm just going to delete it. This is the actual source code, the main.odin. So I'm going to delete that. And I can just make it again. I'll call it main.odin. There we go. We're going to call it package. So I'm going to kind of reference my code over here just so I remember what I'm doing. Sometimes I have it on another screen, but I'll just look at it here. So we're just going to call it package main, and then we're going to import a couple things. We are importing core format. This gives us access to a formatted print, which is going to be like printf or printf ln for print formatted line. So that package that we're importing is going to give us access to that. And we're also going to pull in core OS just so I can give it an exit code when we close the program. Okay. And we're just looking through these. And then we're going to import from the vendor SDL2. And that's going to automatically work for us. So I'm just going to start off with bringing these in. So we're going to import those. I believe it was core. And we want format. And core OS. And this one is going to be from the vendors. So this is SDL2, the SDL2 binding for the C library SDL2. I'm sure you already know what SDL2 coming into this is, but it's just the Odin binding for SDL2. It's going to be almost mapped to it one-to-one. It's going to live very close to being the exact same. There are subtle differences, but it's pretty much mapped as close as possible. So vendor, and I think it's just SDL2. So let's make a main function, and it'll just be called main procedure. Sorry, not a function. The main proc. It's not taking in any parameters, and it's not outputting anything. I feel like I'm doing this wrong. Is it 1 or 2? I can never remember. It is 2. Yeah, okay. We can do a printf. I'm going to do print line and say hello. And actually, what I'm going to do is I'm going to say success. And then I'm going to do it again. And I'm going to do it ePrint ln. And I'm going to say fail. And then we could os.exit. And we could put a 1 here. Let's just do this for now. I just want to show you a couple things real quick. So the first one is print. Now, this is printf. When I save it, unlike other linters, usually when I come out of insert mode and I go back into normal mode, the LSP or the linter would check. On OLS, instead, it actually checks when I save the file. Not always, but some of the checking happens. So if I hit W right here, it'll tell me any mistakes I've made. It looks like I haven't made any just yet, so that's good. So we have this printf. We can have print line. Let's just do print line. We don't need printf. So print line prints a line. If you've seen this in other languages, just print will print something, but it will not advance it won't advance down to the next line. So if I print out hello right here, it will not go down to the next line. It'll stay here. So if I have another print, if it says print fail, it'll just say fail right after it without going down to the next line. And I could just put a new line character in here, and that would sort it. Then it would go down to the next line. But if I just use print ln, the same thing happens. It advances down to the next line. Okay. The printf version allows us to do other things, to use variables and build up a formatted string. I'm not doing it right yet, so let's just take out the f from here. So this ePrint line is different. This one is printing to standard out, and this one's printing to standard error. So we have std in, which is 0. Then we have 1, which is std out. And then we have 2 is std error. Okay, so anytime I'm typing something, it's standard in from my keyboard. Something being printed to the terminal is standard out, and error messages are going to standard error. A lot of times error messages do also go to the terminal as well, but you can redirect them and other things. But they are different. So this one right here is printing success to standard out. This ePrint line here is printing fail to standard error. Okay, so we'll just compile this and look at what this does here. I'm also using this OS exit with a 1. This indicates that a failure has happened. So I want to build this. I'm going to just use the run command. Okay, so it says success and fail. Now, if I'm using the fish terminal, so if you were in bash, if I went echo, I think it's question mark, like this, but this will not work in the fish shell that I'm in right now. This would give me the exit code of the last program that was run. I think it's status in fish. It's the same thing, but it's because I'm using fish, not bash. So I should get a 1 out of this because this program should have exited with a 1, which indicates an error occurred. And it did. So if I change this to a 0, and then run it again, 0 is usually successful state. Okay, so let's take a look at this success and fail. If I were to redirect, I'm just going to run it with the main instead of recompiling it. If I were to redirect standard error to null, to dev null, which is the black hole, it just makes it disappear. It redirects it to the null file descriptor, or that is just nothing. It just doesn't go anywhere. So now we just have success. So we've taken 2, which is standard error, and we've sent it nowhere. We've made it disappear. So we still have success. So let's see if we run it again, but we redirect standard out instead of standard error. Now we have fail, okay, because fail didn't get redirected. Only standard out got redirected. Standard error did not. So we could redirect both of them. We could do this 2 goes into the file descriptor of 1. So we're saying, hey, everything that's on standard out, redirect it to dev null, and everything that's standard error, redirect it to standard out. And these could be either way. It doesn't matter. It should basically not say anything now if I've done this correct. And we got nothing. Okay. So this is kind of important because I'm going to be sending all my messages to error print line, actually error printf line, not print, because they're error messages. And you might want to capture those error messages somewhere else or send them somewhere or do something with them later, but they are error messages. So I'm going to be sending all my error messages to standard error, not standard out. And I'm also going to be using this exit. So I just want to explain that real quick. I'm going to move on past that now. But if you see this E, this is basically, instead of standard out, it's going to standard error. Okay, so the very first thing in SDL is we need to initialize SDL. So this is just the C. This is the website for the C version of SDL, the standard version. And it's SDL, all capitalized, and then underscore, and it's init, as in initialize. So the SDL is capitalized, underscore, and then the capital I. And what it's going to look like in here, do I have init? Yes, I do have init. So this is the same thing, init. It's not SDL underscore init, it's just init. And if we look here, what it's taking in, it says it wants to take in a unsigned 32-bit integer flags. And this gets a little bit complicated, but basically it can take in multiple flags and they're bitwise ORed together and to get a final flag. And then it's going to return a 0. So the actual Odin version is also taking in a bit set, and it's returning in I32. Okay, so it's also taking in a flag, and it's returning an I32. now the SDL one says SDL underscore, and this one doesn't say that at all. But the way that we bring the package in, and I believe I did it wrong. Let me just check my, I said it wrong up here. Right here. I'm going to import it as SDL, as just SDL. Okay, so I'm going to import this SDL like this. So I could use capital SDL. And what would happen is all my commands now would be SDL, but not underscore. Instead, would be dot. So I could say init. There, and it would be the same as like the C version if it was just an underscore. Now, I don't want to write it in capital every time because I'm a little bit lazy. I just want to write it like this. So I'm going to bring it in as SDL, non-capitalized version. But let's talk about the flags. We could look at it either way. Does it... I'm just going to search it here. I know exactly what I'm searching for. So it's this init everything. I'm not sure how far away this was from it. But these are the flags that could be given. And they're the same in the C version of the website. So really, no matter which version you read of the website, we're going to have a similar thing. So here are the same flags here. And just for laziness, and I just want everything, all systems up and running, I'm going to do the SDL init everything. So here it's going to be init everything. It's just the SDL part is missing. But we're still going to be using it because we brought in with the name SDL. So I'm going to use this everything, but I'm actually going to put it as a constant. So I'm going to call it SDL flags. And I'm going to just set it here because we could change how this is later, or we could add other flags depending on which one. So I'm just going to put them up here so that in my code, I don't have to hunt for it in my code. It's going to be right here. So I'm going to say init and everything. So I'm going to set it like that. And then in here, I can just use my constant. Okay. So that's how I'm going to initialize SDL. But I do want to check to see, if this was successful or errored. So if we look back at my code here, I am doing it right here. So what I'm doing is I'm running this command. Now this command gives me back a 0 if it's successful because it's coming from the C world, and a lot of SDL C stuff gives you back a 0 when it's successful, and it gives back usually a -1 if it fails. So I'm usually looking for a 0 for success. Now in C, I could just treat this as a Boolean and just say if, but in Odin, I do actually need to check, since it is a 0 and not a Boolean, I do need to check if it's a 0. So basically, if it's not a 0, something bad happened, and I want to print a message. And I'm just going to grab this real quick. We'll just see what this looks like. So we have the same code here, but I'm just going to put it in here. So this SDL init, and we have our SDL flags, but the output of this function is going to be 0 if it's successful, and something that's not 0 if it failed. So I know 0 is good. So if it's not 0, bad things happened. So I'm going to send a message. Now I'm using the other one here. I'm using eprintf. That's the sending it to the standard error, and it's the formatted one. That's so I could get this error message and add it to the message I've created. So I'm having this string right here as my message, but this is the formatted version. So I can use the %s to say that I'm going to be adding a string in, and this is returning a string. This string goes right here, and then there's a new line. Now I don't need this new line actually. I could do this and say ln here, and that will be equivalent. Basically, if this fails, let me just add in the correct. If this fails, I just want it to print an error message, right? So this is my error message, error initializing SDL, and I'll say SDL2. Error initializing SDL2, and then colon space, and then this %s. This %s is this guy. So what is this guy? This is getting whatever the internal error from SDL. So SDL, some error happened within SDL why it didn't get initialized, and that's going to give me the error back. This is always going to return back the error. So I'm basically just building up a string with the message that I'm putting in and the message that then came from SDL, and I'm sending it to standard error. Okay, so that's the story with that. And what I want to do is I actually want this to be in its own procedure. So I'm going to make a procedure called Initialize. And I want to send a Boolean back from this. I'm going to be using a Boolean to show if something failed or not, if this procedure finished with a success or if something failed and exited early out of it. So I'm going to return a bool. I believe that's the way I have it in my code. Oops. Yeah, I'm returning a bool from this. And I'm also bringing in something here. We'll get to that in a second. So this says I have this name of my procedure. It's called SDL Initialize. I'm just going to call it Initialize because I'm actually initializing things later that won't be SDL. We have the double colons, we have the procedure, and then this is basically a pointer to a game struct called G, and then it's returning. That's the argument it's receiving, and it's returning a bool. So you'll see here when we fail out of this initialization and we print this message, then we return out of this procedure with false. So this false right here will be this Boolean that's returning. Okay, so here's the Boolean. This is going to have an input later, but I'm just going to remove this here, put it in here, and I'm going to return false, sorry. And underneath it, I'll just return true. So this is going to happen. If it is 0, it's going to keep on going. It's going to return true. But if it's not 0, it's going to print the error message and it's going to return false. When I put more things in here, it's going to return early if it ever fails. Wherever part it failed at, it's going to return early. If it gets all the way to the bottom, it's going to return successful. All right. And I also want to be able to call this. So what I'm going to do is I'm going to keep track of the error status. I'm going to say the exit status is 0, which means successful, unless something goes wrong. If something goes wrong, then I'm going to change it. Yeah, I haven't talked about this struct yet. We haven't talked about that. I just want to call this one. So this is just going to, again, it's going to return early. This isn't returning a bool or anything, so it's just saying return, but it is setting the exit status. And we do have this defer exit. So that's how I'm doing this whole thing. So let's kind of set that up. So we can defer things. Oh, we have the exit down below. I'm going to delete that. I'm going to defer exit. And I'm going to say exit status. And up here, I'm going to create that. And this is just going to infer the type. It's going to be an int. And I'm going to get rid of this one. So what's going to happen with this defer close here, this defer OS exit? So right now, exit status is 0. So that's what 0 is going to be right here. And this defer says whenever we exit the scope of this main procedure, we are going to run this function when we exit the scope. So however we're exiting it, doesn't matter how we're exiting it, this is going to run afterwards. So what I could do is I could say, since this is returning a Boolean, I could say if initialize about not? And then I could set the exit status to 1, and then I can just return. And when I return from here, this is closing it down. So this procedure, if I return from this procedure, we're done. And this is going to kick off right away. So I've changed exit to 1, and now this is basically going to be called. I'm going to get rid of this. Hopefully that makes sense. I'm basically setting an initial exit status to 0, which is good. I'm going to try to run this initialize procedure up here. If it's successful, it's going to ignore it, and it's actually just going to close because there's nothing else. So this defer is going to run, and we're going to have success. It's going to exit with success. But if something goes wrong, if this procedure up here returns false, that means this initialize will be false. And this bang right here is a not. So if it's not true, as in if it's false, run this code. Okay? So if I were to do this, if this came back successfully, it would say, oh, something went wrong and closed it down. But I want to say, no, if it's not successful, close it. Okay, so is this enough code to run here? So we can check our exit status already, and we also see if we have an error message. So let's just try this. So that compiled it and ran it. Nothing happened. We didn't get any error message here either. So let's look at what the exit status was of this. And it's 0. So that means everyone went okay. So if I were to remove this, save it, and then run it again, we should get an error message this time. Oh, sorry, not an error message because it didn't. The check happened here, so we should have an exit of 1, but we didn't get an error message up here. So let's check that out. Let's see if the echo status gives us a 1. Okay, so that is working. So I'm going to fake an error here. So what's going to happen is we're going to get my message, but we're not going to get anything after it because a real error is not occurring. So I'm just going to change this to equals 1. And so we should get an exit status of 1, and we should get this error message. Okay, error initializing SDL, but you see how there's no other message after it because a real error didn't occur. I faked the error. So this SDL get error right here didn't actually get any error because 1 didn't occur. Let's check our exit status. And it's 1. So it all looks like it's working correctly now. Okay. So to be able to draw a window, we need to initialize SDL, we need to create a window, and we need to create a renderer. Okay? So up here we have done this SDL init, and we just use the flags initialize everything. Later on we'll talk about what this means, why they can be ORed together. They're bitwise ORs, but since we're not doing it in this one right here, I'm just going to skip it because we will hit it later. And we do know that most of the SDL stuff in C returns 0 on success. So we're going to see that a lot of times. So I'm just going to close this. The next thing we need to do is create a window. So for this one, we're going to need a pointer. And it's going to be just like this. And if we look it up here in Odin, we're going to notice that it's the same thing. It's going to be create window. So this create window, it needs a C string. It needs some I32s, a X, a Y, a width, and a height. And it also wants some flags too. And you see right here, it's returning a pointer to a window. So this window is going to be SDL.window because we have brought it in as SDL. So everything's going to be prefixed with SDL. Okay, so at this point, I'm going to make a struct, and I'm going to hold all these things into the game struct. Let's look at how I've done this over here. So right here, I'm just making a struct, and I'm holding the pointer to the window in it. And later on, I'm going to hold a pointer to the renderer as well. And you see that they're prefixed with SDL. That's because of this import up here with this SDL here. And I do have some other, the window title and the screen width and the screen height. They are constants for just the string and the width and the height. So I'm going to set that up. I think it's window and screen. That's how I did it. Yeah, window and screen width height. Window title. We'll say this is 01 open window. These are just constant names I'm making up. You don't want to clash with something that already exists. Sorry, this is not an equal, it's double colon. I've been programming in other languages too long. So double colon for a constant. And we're going to have, for the width, we're going to have 800. And screen height is going to be 600. Okay. And I also want to make this struct that is right here, this game struct. And I'm just going to call the member window. And this is going to be window. And the type of this is going to be SDL. It's going to be a pointer to SDL window. Yeah. Okay, and that's just how it is here. This is the type that it's returning. So I'm going to be capturing it inside of the game struct. We'll put a comma right here. Let me just make sure there was no. I want to see again real quick. Yeah, that's how I want it. And this is going to be the create window. It really looks the exact same for both versions. So this create window is taking in a C string, and then it's going to be 4 I32s and then flags. Now we can see these flags here. But we're going to talk about these flags in a second here because they're supposed to be optional and it's not immediately apparent. Hold on one second. Let me back up here. Yeah, this is not immediately apparent to me that they are optional. And I believe that I can see that they are, but I may or may not be right about it. So this, and we are going to use some, let's see here. I'm not sure. They have a default, where is it? This window pause centered. That's probably here too. Let's just find it. I know it exists. I just want to see that it exists. Here it is, right here. Window pause centered. So these are. It's easier to read on the SDL site. So basically, for the X and the Y position, you can have SDL calculate it for you, so it's just centered. So you can put this SDL window pause centered. And for us, this first SDL will be the small SDL with the period, but it will be the exact same for the X and Y. And then for the width and the height, we'll use the constants that we created earlier. And then for flags, this one gets a little weird. I'm going to use the window shown one real quick, but then in a little bit, I'm going to show you that they're supposed to be optional, but it's not apparent that they're optional. So for the very first thing, I'm going to use the constant title. I'm going to use the window pause centered for the X and the Y. And then I'm going to use the screen width and the screen height constants. And then I'm going to make another constant that holds flags. and I'm going to put the SDL window shown. It's here somewhere. Window shown right here. So that's what I'm going to be doing for this. So again, you can use both of these. It doesn't matter if you use the C version or the Odin. They're almost the exact same. So here, that is the function that we need to call. So I already know that it's going to look like this, SDL dot. And then it's going to take in all those things. So right away, it's going to take in the window title. And then for the X and the Y, I'm going to do the SDL window pause. I think it's just centered. Yeah, centered. And I'm going to do that again for both the X and the Y position. And it's not I centered. So that's the C string. That is the, well, if we just hover here, we can see the, right here, we have the title, we have the X, we have the Y. Now we need the width and the height, and then the flags. And I'm going to let this break to multiple lines because it's big. So now I'm going to use the screen width and height constants that already exist. And the last one is going to be the flag. So I'm just going to use another constant for the flag. So I'm going to write the constant in now, and then I'm going to make it above. So it's going to be, what did I call it? Screen flags or window flags? Window flags, okay. And this one is going to be SDL, and it's going to be window shown. Right down here, window shown. There's a reason why I'm doing this. This is going to become apparent a little bit later, because you can have multiple flags using a bitwise OR operator, and they'll build up. So that's why they're up here, and I don't have to look through the code for them later. So I'm just using them as constants up here, and they can be changed here. And we're going to mess with this in a little bit too. So right here, we need the window flags. And that should be everything for this. Now, this is returning a, we want to capture it in this window here. So we are going to change this because we need to get access to this. So we haven't made it yet. Down here, we need to create it. So we're going to create an instance of it just on the stack. It's not going to be heap. I'm just going to call it game. So it'll just be game. Yeah, that should be right. Okay. And I need to pass it in. I want to pass the address of it in. And so the way I pass it in up here is I'm just going to call it G internally here. So I'm going to say G, and I'm going to say it's a pointer to a game. So this is going to be a pointer to a game struct, and it's just going to call G, and I've passed it in down here as the address of this. So this is just the actual game struct, and I'm passing in the address of it. Here I'm looking for a pointer, that's the address of it, and I'm just calling it G. So now here I can say G window equals, and then I can check it. So the way I'm going to check this is to see if this is null or not. So in Odin, whenever you declare a pointer like this, they're always initialized to nil. So if this is still nil, if this fails, it will actually also return nil. So this is nil to begin with. If this fails, it returns nil. So all we need to do is check to see if this is nil. If this is nil, something happened. So down here, I'm going to say if g window equals nil, then I want to do something. And I want to do something that's very much like this. So I'm just going to yank this up here, put it here. And the message we have is we have error creating window. Okay, so error creating window, it's still an SDL error. We're still returning false out of here because something went wrong. Let's just compile this and make sure, or I'll just save it and see if Odin complains, and it is, okay. Invalid type, unfilled window. This is supposed to be capitalized. Oh, that was all of it. So this wasn't capitalized right here. So down here, it was saying, I don't know what you're talking about. I don't know what this capital game type is. And then just everything else based on that failed. Okay, so the LSP kind of helped me out there. And now let's just run it. And nothing's going to open up yet. So we haven't got to opening a window and displaying it yet. So, but I just want to see if there's any errors. Let's check the status coming out. Looks good. Okay. So we have this window open right here. Creating window. We've done all that. And again, we're looking for this function failing. We're looking at whether this pointer got populated or not. If this fails, this pointer does not get populated. So that's how we're looking. And that's going to be the way it works on most of the SDL stuff. Anything that's returning a pointer, if the function fails, it doesn't populate the pointer. Or the pointer will still be nil, rather. So the render is very much the same thing. So again, this will be small SDL period and then create render. And we're looking for a pointer to a window. We've already made one. And we're looking for an index, which I believe I use -1. Initializes the first supported, yeah. So this index right here for me is going to be -1, so I can just let it default to the first available. And then we're also looking for flags. And for the flags, again, we're gonna, after this sets up in a show window, we're gonna start looking at these flags a little bit. But where's the flag shown here? SDL render flags. Okay, so this is supposed to be optional as well, as in you don't need to put any flags and you could just put 0 there. But in Odin, you can't put a 0 because it'll complain, but you can put nil, but it is not documented. And so we're going to test this out. So these are kind of the hexadecimal of software of render accelerated. Now, if it's nil, none of these should be set, but we're going to use this one right here, and then we're going to look at afterwards what happens if we put nil in there. So I'm just going to copy this out of here and make another constant up here, and I'll call it render flags. And this will be SDL dot, and we're going to call it render accelerated. This is not how I like to do it. I kind of got tripped up here, but we're going to look at this. I don't need anything else. So after we've created the window and we've made sure that the window does exist, we do need to capture this again. And this is very much the same thing. This is going to be called renderer, and it's going to be a pointer to a render. SDL should be like that. We can look at the page here, It'll be the same on both, but so this is returning an SDL render, SDL create render. So this is up here already created. So I'm going to capture it, the G render that we just put up into the game table up there. And this is going to be SDL create renderer. And the very first thing it needs is a pointer to window, and we have one. It's called G window. So here's the first thing it needs is this pointer to a window. The second thing it needs is this index that I'm going to use -1. And the third thing it needs is the render flags. For us, we use hardware accelerated. So render flags. And again, this is returning a pointer to a renderer. So if this fails, this pointer to a renderer will still be nil. It's currently nil before this function runs. If it fails, it's going to be nil again. So we can just check it right away. Or we can just copy this one right here. I'm just going to yank this. And we're checking render. And this will be error creating render. And we're still getting the SDL error. We're still returning false. That should look like that. I'm going to see if this compiles still. And exit status is good. Okay. Okay, so we're getting very close now. Now we have initialized SDL. We've created a window. We've created a render. We have pointers to them in this game struct. We could display something. So we do have this defer exit. We're not cleaning anything up yet, which is not good. We should be cleaning up behind ourselves. So there is a game cleanup. And the first thing I'm going to do is make sure game as the pointer is populated itself. And then if it is populated, I'm going to see if the render is populated. And then I'm going to destroy the render and destroy the window. So I'm not sure if I opened these up. I don't think I did. These are both very straightforward. They don't return anything. They're just destroying they're releasing the memory that was allocated into that pointer. It's under the scenes. It's whatever SDL did to, it could have structures and everything else. It's cleaning up all that memory for us. So this is the standard way. We are going to destroy the render. We're going to destroy the window, and then we're going to shut down SDL. And they're all very simple. They just do one thing. They don't really. We're not checking if they failed or anything like that, but we do want to check if the pointer is populated. But I believe that these actually can handle if it's not. If window is null, the function will return immediately. Yeah. After setting a SDL. So it does say invalid window. Yeah, it does set an error message. We're going to check to make sure it is valid before we do that. So we'll call that game, was it game cleanup? Game cleanup, yeah, okay. So game cleanup, another procedure. And it's going to have the same access to the game struct. And the very first thing we want to do is we don't want to be cleaning up stuff that's in the game struct if the game doesn't even exist, right? So we kind of want to check if the game pointer is actually even populated before we do anything. So if G is not nil, So if it's not nil, then we need to start cleaning things up. And I want to clean up things in the reverse order. So the very first thing I did was I initialized SDL. And then I created a window. And then I created a render. So the very first thing I want to destroy is the render. And then I want to destroy the window. And then I want to quit SDL. Okay, so I'm going to do them in reverse order. So the very first thing I want to do is the render then, because that was the last thing that I made. But I do want to check to make sure that it is valid pointer first. So if g.render is not nil, then I'm just going to do it all in one line. It's cleaner for this one. So if it's not, I'm going to do the SDL dot destroy render right down here, destroy render, and the render. So that's the whole thing right there. And the window is going to look very much like this. We need to release its memory as well. So window, and this is going to be destroy window. It's almost the same command. And this is going to be the window here. And the last thing that we want to do is to actually quit SDL. And it takes no parameters and it doesn't return anything. It's just SDL quit. Okay, so we have this. So how are we going to call this? Well, what I'm going to do is I'm going to defer this as well, but I'm going to defer it before the other. So I'm going to put it up here. And we'll say game cleanup and pointer to the game. So this is going to, whenever this goes out of scope, the main procedure finishes, it's going to first call game cleanup, and then it's going to OS exit with whatever the exit status is. Let's just make sure that this is working. I'm just going to put something in here. I'm going to say fmt print ln all clean. Now that should have run, and it should have said all clean, and it didn't. Let me double check everything that's going on here. I'm just going to check some print statements in and see what we get. Okay. Just going to put this in the very top level. Okay, so game cleanup is not being called. I'm just going to put this down here and not defer it. Okay. I wonder if it needs to be below it. I'm sure there's a super good explanation. It's a little bit late for me, so I'm probably making silly mistakes here. I'm going to change this. I just want to check to make sure the other defer is working. And now I'm going to echo. Okay. So it's just out of order here. So it looks like I need to defer the OS exit first and then afterwards, so that this runs first and then this runs. I guess I had it backwards in my head. I'm going to change this back to 0. And we had some test here. And I'm going to remove this one. Okay. So that's cleaning up, like I said, we're cleaning up the render first. We're making sure that this pointer is an actual non-nil pointer, and then we're destroying the render. We're making sure the window is a non-nil pointer, and then destroying the render, and then we're quitting SDL. So whatever we allocate for SDL, we do want to make sure that we clean up after ourselves as we're going along. So we have this cleanup procedure, we have initialize procedure. So what we need to do now to actually see something is we need to, we're probably having a window open, and it's opening and closing so fast that we never see it. So one of the things that we can do in SDL is we can set a delay, SDL delay, and it's in milliseconds. So if we want to see this window open that's not going to be drawn correctly, we could just put a timer on it, right? So we can go SDL delay, and we'll put, say, 2000 for 2 seconds. And this is probably going to open a window that doesn't quite look right. There it is. There's a window, and it doesn't quite look right. Let me do it again. I'm going to change it to 5 seconds. Okay, and I'm going to move this around. You're going to see it's not right. And we'll fix that. We need to clear a render and present a render. So let's see here. So clearing a render, and it returns whether it failed or not a number, but anything that happens in a game loop, I kind of ignore the error unless it's major. If it's a rendering then that's going to happen for 1 frame, I usually just ignore it when it's inside of a game loop, unless it's a major problem. When I'm loading resources, I pay attention to the error messages, but when I'm in the game loop, I ignore them. So I'm going to ignore this one. The basic function is just clear the render, and it just takes in the render. And then the next one is presenting the render. And it's this one doesn't even return an error, but it's render present, and it takes in the render too. And this should give us a correct render. So the 2 things that we need to do to show something is the render clear. That clears our render, so we can paint to it. It's going to clear it to black. And then the present is going to actually make it where it's a visible, something that we can see. So we're going to have a black screen, basically. I feel like yeah, there we go. Render clear. And this is going to be G render. And then SDL render present. And this again is just going to be. Now, the first one, the render clear, actually returns an error that you can capture. But again, inside of a game loop, well, this isn't a game loop right now, but in the next video, it will be. I don't check errors in a game loop if they're small things. So this should actually give us a window that opens up for 5 seconds. And it's not G in this one, it's game. There we go. So we should have a black window open this time. There we go. And if we look up here, it says open window, which is the title. For me, I'm using a floating window manager, but this title right here is being set. So wherever your title for your window manager is, again, we can see it written right up here. It says open window. Okay, I'm going to grab this in. I did want to show this off here. I kind of wanted to show this part here where I said you should be able to not add the flags in, but let's see here. So for this create window, this Windows flags here, this should be optional. And in C, you would put a 0 here if you want to set no flags. And you can actually set nil here, but I wasn't entirely sure if nil was like a valid option, even though it didn't complain about it. And then down here in the renderer, usually I don't want to put a flag there because I want it to try to accelerate and then fall back to software if it can't. And I believe if you put the acceleration flag on it that we chose up here, it will crash if it can't get accelerated. So I usually put that as 0 too, but if I try to put this as 0, it will not let me. So watch this. If I set this to 0, it's just not going to like it. It's going to be the wrong type. And the same thing here. If I put 0 here, it's going to be the wrong type. So, but we can put nil, which is not how you would do it in C. Let's see here. Where's the other one? And it accepts them. Okay. And it still works. It still works just fine. Let's try it. Okay, so we know that this still works. So what I'm going to do here is I'm going to uncomment these. And I just want to show what the flags are being set for SDL for the render and what the flags are being set to the window. So this should print it out for us. And I have them both set to nil right now for the flags. It put it as accelerated. That's the hardware accelerated. And the other one is 6. Now, if we look over into this, let's see, it was, okay, so no, that's not it. There's the window flag shown. So this is set to 6 and accelerated. So what if I were to change it? I'm going to change the create window. I'm going to put it to SDL window shown. And for the renderer, I'm going to set it to software. Render software. Okay, so this is shown. This should be, I believe, 2. Let's see, where is it? Shown is 2. And software won't tell us a number. It'll actually say software here. I'm not sure what's going on with the window one, but the render one does say software, okay? So if I change it to the flags, it is hardware accelerated, right? Accelerated. So this should change to accelerated or hardware or whatever it was. It changes to accelerated. Now, I can put it on nil, and it still says accelerated, and I don't understand if that is meant to happen. Or if it's going to fall back to software if the hardware acceleration is not available. I'm setting it because I actually don't know the answer to this. It doesn't explicitly say if you're supposed to be able to use nil or not. So I just kind of want to show where I'm at with this, but I'm going to explicitly set them like I've seen other people doing. Again, I prefer it to be 0. I'm going to use the explicit one because I don't know if this nil is the right answer or not. So right here, I'm going to use my window flag. And which is the window flag is the shown option. And the render, I'm going to use the render flags, which is the accelerated one, the render accelerated. Again, I think it should be nil, but it doesn't say it anywhere, and I don't understand. I don't know enough about Odin to know if that is correct or not. So I just kind of wanted to show that, even though it didn't show both of them correctly for me because I thought this window thing was going to show differently. But at least we got the render flags. And yeah. So I've explicitly set them, but normally I would put 0 on those if I was in C or C++ or something. Okay, so that's how you kind of set everything up. That's how you open a window. SDL is double buffered, so it's going to clear a buffer that it's not showing you. And then when you choose the render present, it's going to flip the back and front buffers. So it's going to clear the back buffer that's you're not seeing. You're being displayed the front buffer. It clears the back one. You can do all your drawing on it. We're not drawing anything to it yet, but you can do all your drawing on it. And then it's going to flip the buffers, which is just flipping pointers. And the person playing the game or the person looking at the screen will immediately see everything that was drawn on the buffer. And that's what render present is doing. So this is a way for you to draw on the buffer and draw all your elements and then flip them immediately. So all we're doing is we're clearing the buffer, we're presenting it, which is just a black screen for us, and then we're keeping that window open for 5 seconds, and then we're shutting down. Okay, so this is a little bit of error handling. We are initializing things. We are also cleaning up after ourselves and shutting down SDL. Okay, so that's going to be it for this one. Hope you enjoyed that. Hope it was entertaining or educational, and have a good day. Bye.